of the decoder. So what is mean by expansion of the decoder? So to increase the decoder's capacity, to increase the output functionality, output capacity of the decoder. How to increase? That means, for example, we are having the 2 by 4 decoders. Okay, we don't have the 3 by 8 decoders with us, but I want to connect 3 inputs and to get the 8 outputs. Is it possible or not? Anyone? We are having only 2 by 4 decoders. We don't have 3 by 8 decoders, but I want to construct 3 by 8 decoder. I want to construct 3 by 8 decoder and I want to get 8 outputs. Yes. Is it possible or not? I am asking you people only. Yes, ma. You can tell either yes, sir, no, as per your knowledge. Nothing will happen, no?
Yes, ma'am.
Yes. So you can combine the 2 by 4 decoders, 2 by 4 decoders to construct the 3 by 8 decoder, because in 2 by 4 decoder, how many inputs are there? In 2 by 4 decoder, how many inputs? 2.
Two.
And coming to the outputs, 4.
Four.
Like that other 2 by 4 also we are having 4 outputs and 2 inputs. Okay, 2 inputs. Overall, how many outputs are there? How many outputs both combined?
Eight. Eight, ma'am.
8 outputs. 8 outputs. If you construct 3 by 8 decoder, 3 by 8 decoder, how many outputs will be there?
Eight outputs.
8 outputs. So here output is same. So based on the, to get the output, to get the 8 output, we are going to discuss about how to connect here these two inputs and these two inputs. For 3 by 8, how many inputs are there?
Three inputs.
How many inputs? 3. But coming to here, 2 plus 2, 4. Right? Yes or no?
Yes, ma'am.
Yeah. But here the thing is we cannot modify the output, but we can design the inputs. We can design the design the decoder by thinking in logical manner. That means you can have the 2 inputs or 3 inputs. How? So first thing here, I am drawing 1 2 by 4 decoder. Okay, 1 2 by 4 decoder. So for this 1 2 by 4 decoder, how many outputs are there? 1 2 3 4. What are the outputs? D0, D1, D2, D3. How many inputs will be there, ma? Yes,
Four inputs, ma'am.
A0, A1. And is there any other input for 2 by 4 decoder?
No, ma'am.
Then how the circuit works?
Enable,
Directly it
ma'am.
will
We
be
have
there.
enable.
Yes,
By
enable,
enable one.
enable. Yes, yes. So I am writing here enable as the third input. Okay, I am considering that third input as A2. As A2. A2 will work as enable. A2 will work as enable. Now, so this is a simple thing. We are having 2 inputs and 4 outputs. One enable. That enable is represented here as A2. Here as A2. Okay. Next, like that we can have one more encoder. One more encoder. Sorry, decoder. So T 2 by 4 decoder. What are the other 4 outputs? If you consider this as the single one, what are the other 4 outputs, ma? What we are doing, we are combining 2 decoders. Okay. First decoder outputs are D0 to D3. Yes, D4, D5, D6 and D7. What about the inputs? I am taking the same inputs. Okay, I am taking the same inputs as it is. Next, enable. Every decoder will have the enable input, right? If you enable once, any one of the output will be active. Yes or no? If E equal to 1, any one of the one output will be active, right? If E equal to 0, no input and no output. Yes or no? No input and
Yes, ma'am.
no output. So if I write E equal to 1 once, that means if I give A2 equal to 1, then what will happen? For example, if I connect in the same manner, what will happen? Here also if I write E, if A2 equal to 1, which output will be produced based on A0 equal to 1 and here A1 equal to 0? Which output will be produced, ma? As per the definition, any one of the output will be should be present, right? But here enable is the input which is applied to both decoders. So here one input, one output will be, and here also one output will be active, right?
Yes,
Are you
ma'am.
following?
Yes, ma'am.
That means here at a time here 1 0. 1 0 means D2. Here also if you say 1 0, this one second one will become active, right? But here the thing is at any time only one should be active. So I want to make it like if this works, the second one should not work. Okay, because otherwise this input will be active and here this input will be active. Yes or no? If you supply A2 as it is for the first decoder and second decoder, for the first decoder and the second decoder, what will happen? Here you will get one output, here also you will get one output. But but at any time only one output should be active. I want to make it as single decoder functioning as 3 by 8, right? 3 by 8. So out of 8 outputs, only one output should be active. Here what is happening? Here one and here also another one. So both are in active mode, but I want only one from D0 to D7. So is there any solution? The simple solution
Invert
is
enable, ma'am.
yes, invert enable. Very good, very good. So I'm inverting here. Okay, I'm inverting here. So first thing, if the first decoder works, second decoder doesn't work. Okay. Now we will see by taking one example. Okay. By taking one example. So for example, I am giving A2 equal to 1. A2 equal to 1. So A2 as 1. A1 is 0 and A0 is 1. If A2 is 1, A2 is 1. If A2 value equal to 1, what about this E value? What about this E value, ma? What about this E value?
0, ma'am.
0. It is inverted. It will be inverted. If E equal to 0, then this doesn't work. Then this decoder doesn't work. And what about A2 equal? So the next thing is second. If A2 equal to 1, this decoder works and the inputs will be forwarded. Input will be passed. So what is the input here? 1 and 0. and here A2 is 1 as it is. So for 101 combination, which output will be active, ma? For 101, which output will be active? D5. D5. 101 represents what? D5. D5. For example, if I take A2 equal to 0, okay, A2 equal to 0, then what will happen, ma? If A2 equal to 0, what will happen? A2 is 0. Next, if you supply 0 here, it doesn't work, right? The 2 by 4 second decoder doesn't work. What about complemented value equal to 1? So if this equal to 1, the first decoder will work. First will be forwarded as it is. So A2 value is 0, A1 equal to 0, and A0 equal to 1. 0, 0, 1. Which output is active, ma?
D0.
D
D1.
D1 001 001 means D1 will be in the active mode. That means here with the help of small decoders you can construct the large decoder. Also you can expand the decoder. Here we are expanding the 2 by 4 decoder into 3 by 8 decoder. The simple logic is every decoder will have only two inputs. The same input will be supplied to both the decoders, right? So the thing is we want to make it as a single as 3 by 8. Okay. 3 by 8 means 3 inputs should be there and 8 outputs will be produced. What are the 3 inputs means here? The first thing is 2 inputs as it is, which will be supplied to both first decoder and second decoder. Next, the third input A2 will be divided into 2. That is, it will be used as the enable because for the 2 by 4 decoder, the actual input should be 2 only. The third input will be enable. But coming to the 3 by 8 decoder, actual input should be 3. So this enable will act as the third input for the 3 by 8 decoder. So so here two decoders are different, but we want to work with combinedly. Okay, so for that purpose what we are doing, we are inverting e value, we are inverting a2, we are inverting a2. One will be supplied as it is and another will be supplied by inverting, and this will be connected to e, this will be connected to e. When enable won't work, if enable equal to 1, then that circuit will work. Okay, is it clear for everyone?
Yes, ma'am.
Is okay, simple logic, ma. If one works, second doesn't work. So for that purpose, we are taking inverter here. Why that should not work means if the same will be supplied to two decoders, what will happen? Two decoders will give the output, but it is contradiction to the decoder definition. So what we are doing, we are making it as single. That is, if the first decoder works, second decoder should be idle. If the second decoder is working, first decoder should be idle. So what is the process to make it in non-working mode means the only one thing is E, because based on E value only the circuit will take the inputs and will give the outputs. So what is E? Enable. If enable is active, then only the circuit will work. If enable is not active, the circuit doesn't take any input and doesn't produce any output. Is it clear, ma? Yes.
Yes, ma'am.
Yes,
Right.
ma'am.
So if you want, you can note down decoder expansion. Okay, if the question is asked in the example, you need to draw the circuit and you need to write the explanation of the diagram. Okay. Okay, tell me one thing. If I want to have the 6 to 64 decoder, 6 by 64 decoder is required, but I have only 4 by 16 decoder. So, how many 4 by 16 decoders are required, ma? To construct 6 by 64?
4.
Pardon?
4.
4.
Right, right. Very good. So, 4 by 16 decoders are required to construct 664. Is it completed? Yes, ma, is it
Yes, ma'am.
completed? Right. So the next one is next one encoder. So what is decoder exactly? Anyone? Decoder single output is active at any time, but it is not giving single output.
N puts a maximum of 2n outputs, ma'am. That is equal to n into m. It is called decoder. N less than 2 power n.
Yes. So decoder is a combinational circuit which takes n inputs. Okay. And which gives 2 power n, maximum of 2 power n outputs, which produces maximum of 2 power n outputs. Maximum of 2 power n outputs. So that means here we are giving the n number of inputs and it will give 2 power n outputs and it will give 2 power n. Supply decoder is used for giving the more number of outputs, taking the less number of inputs. But coming to the encoder which performs a reverse operation of decoder, performs reverse operation, exactly reverse operation of decoder. So what is mean by reverse operation, ma? Can anyone?
It takes 2 power n inputs, ma'am, and it
Yes,
produces the n outputs.
very good. It takes maximum of 2 power n inputs and produces n outputs and produces n number of outputs. So encoder is a circuit, digital circuit that performs the inverse operation of a decoder. So it has 2 power n input lines and n output lines. So the output lines generate the binary code corresponding to the input value. That means here actually in the encoder we have given the A2, A1, A0 as the inputs which are binary values. For example, here relating corresponding to this value, any one of the output variable is active. But coming to the encoder, we are giving all the D0 to D7 inputs, and outputs are, A2, A1, A0. Outputs will be based on what? Based on which D value is active. According to that, the output variables will be produced. Okay, how it will be, we will see with the truth table. We will see with the truth table. And another here 8 by 3 encoder. We are discussing about the 8 by 3 encoder, which is also known as octal to binary. Octal to binary encoder, octal to binary, octal to binary encoder. Now, truth table. So, what is truth table consist of? What is truth table?
It
Consists of
contains
input.
inputs and outputs, ma'am.
Inputs and outputs. Possible number of inputs and outputs will be shown in the table. D4, D3, D2, D1, D0. Next, outputs. You can have A2, A1, A0. So in the first case, D0 is active. Remaining all are 0, for example. Okay. Now what will be the output? Outputs represents the binary variable related to this combination. So what we can write? If D0 is active, it means what will be
A naught.
the binary value? Binary value.
A0.
Hmm? Yes, actually in the decoder, what we did, we have considered these three as the inputs and D0 to D7 as the output. Here it is in reverse proportion. Yes, D0 is active. D0 is active means all the binary variables are
Zero.
zeros. Okay. Next 0, 0, 0, 0, 0, 1, 0. Now, where we have one ma? For D1. For D1, what will be the binary values combination ma?
Zero
0.
zero one, ma'am.
0, 0, 1. Next 0, 0, 0, 0, 0, 1, 0, 0. Now, this one is related to D2. D2 is active. When D2 will be active? So here we are supplying D2 input. D2 input. We are supplying the D2 input. Okay. Remaining all are zeros. So here if D2 is supplied, then output will be
0 1 0.
yes, three variables combination which represents the binary data, that is 0, 1, 0. Next 0, 0, 0, 0, 1, 0, 0. Now,
1 0
now
0.
D3, D3, D3 means here
0, 1,
third.
1.
0 double
D3
1.
means D3 input is supplied means you will get the output as 0, 1, 1. Okay, simple thing. 1, remaining all are zeros. That is which is active? D4. D4 means here
1 0 0.
1, 0, 0. 1, 0, 0. Next one 0, 0, 1. All zeros. All zeros.
1 0 1.
1, 0, 1. Next 0, 1. All zeros. So this one is
Not zero.
corresponding to D6. 6 means here if D6 input is supplied, then outputs will be 1, 1,
1,
0.
0.
Right. Next 1, remaining all are zeros. So with this you can have the output combination as
1.
1.
1, 1, 1, 1, 1. Okay. Have you all understood the truth table, ma?
Yes.
Everyone, please keep in the chat box at least. Then I will know whether to continue for the next one or shall I explain again. Because now we are not in the classroom physically to know by seeing the faces. That will be helpful for you people. Yes, ma'am. Shall I proceed?
Yes, ma'am.
Only 4, 5 members. What about the remaining? Okay. So, till now what we have done, according to the definition, we have drawn the truth table, or that means for the 4 by 8 by 3 encoder, 8 by 3 encoder, we are giving the 8 inputs based on the input which is active. Okay, which one will be supplied, based on that output combination will be produced. Now, how to draw the circuit? From the truth table you can draw the circuit. So how means, first, how many outputs are there, man?
3, ma'am.
3. What is the first output? A2. Okay. Now A2 equal to, when A2 will be true, you need to identify. When A2 will be true. From by seeing the table you can say it easily. Pardon?
D4, ma'am.
Yeah, D4. Next, because here A2 is having 1 here. So with respect to this one, which input is active? You need to consider that. Next,
D5,
D5.
D6.
D6, D7.
plus D5. Here also we are having 1. So you need to consider this input plus. Next, here also we are having 1. D6 plus. Here also we are having 1. D7. So from the table you can write. Okay. Next. Next output is A1. Next output is A1. So for the A1 also you need to write in that manner only. So A1, first identify where we have ones in A1 column. So we have 1 here, right? We have 1. So what is the corresponding input for this?
D2.
D2.
D2. So I can write it as D2 plus. Next one. Here we are
D3.
having 1 again. So I can write it as D3 plus. Very good. D6 and D7. So you need to consider D6, D7. Okay. Next, the third output is A0. Third output is A0. A0 equal to,
D1.
D1.
so here in A0 column we are having 1 here. So what is the corresponding input? D1
D1.
plus. Again we are having 1
D3.
here. So D3. Next one.
D5.
Next here it is D5. Next one.
D7.
D7.
7.
D7. Okay, now we are ready with the equations. Based on the equations, you can draw the circuit, right? Yes.
Yes, ma'am.
Yes. Right. Now we will draw the circuit. So here, how many outputs are there, ma? Three outputs. Those are A2, A1, A0. And which gates are required? If you see A2, which gate is required? How you will get the A2
Not gate.
Huh? Yes, ma'am. Am I audible now?
Yes, ma'am.
Yes, ma'am.
Okay. So here for A2, how you will get the A2? For that purpose, which gate will be used? A2 is the output variable and inputs are D0 to D7. So here we are having which operation in between the input variables, ma'am?
Or
OR gate. OR gate. So what we are doing now, D4 plus D5 plus D6 plus D7. If you perform OR operation of these four variables, then you will get the output as A2. So I'm writing the input variables as D0, D1, D2, D3, D4, D5, D6 and D7. Okay. So these are the input variables. Now to get A2, which should be add R D4, D5, D6, D7 will be supplied to R gate. Okay. Are you following?
Yes, ma'am.
Hmm.
yes, ma'am.
So for A2 you can have D4, next one D5, next one D6, again D7. Okay. Next for A1, what is the equation for A1? D2, D3, D6, D7. So all these inputs are supplied to which gate? OR gate, because in between we are having plus 2, 3, 6, 7. So I'm taking 2, next one, 3, next 6, again we are having 7. Okay. Next, coming to A0, D1, D3, D5, D7. D1, 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 this is supplied to OR gate. Next D1, next one D3,
D5, D7.
D5, right, D5 and D7. Okay, this is the logic diagram for encoder. This is the logic diagram for encoder. So is it clear, ma'am? How to draw the circuit? So you can draw the circuit based on the equations, input variables. So how to get the equation means by seeing the truth table where we have one represents that value will be true if it is in as the input variable. Okay, you need to consider